Welcome back. At this point of the lecture, we get to discuss a special type of concentration measurement. This is going to be called molality. And molality is the only concentration that does not follow the pattern of solute over solution. Like mass percentage is mass of the solute over the mass of the solution. Molarity is moles of the solute over liters of solutions. Molality doesn't follow that pattern. Molality, which is a lowercase m, is moles of the solute over kilograms of the solvent. Not the solution, but the solvent. So that's what molality is. And we're going to see that it's a very special type of concentration that allows us to describe some properties of matters like boiling point and melting point that changes the properties of the pure solvent when you add the solute to it. And we're going to call those colligative properties. So colligative properties are changes that the solvent suffers on its properties because you added a solute to it. And all that is based on intermolecular forces. So how do we do a problem like this? We are to calculate the molality. So we know that molality equals moles of solute over kilograms of the solvent, just like I said a few seconds ago. So on this case, we have two quantities. We have 12.5 grams for the ethylene glycol and 130 grams of water. The water has to be the solvent because it's the one on the biggest quantity. So we have grams, but we don't want grams, we want kilograms. So 0.135 kilograms. And you already know how to change from grams to kilograms. And ethylene glycol is 12.45, but we do not want the mass. What we want is the moles. So we can do 1 mole of ethylene glycol is going to be 24 plus 6 plus 32. That's going to be 56, 62. 62.0 grams. So when we do that calculation, it's going to tell us that the molality on this particular case is going to be 12.5 divided by 62 divided by 0.135 kilograms. So the molality is going to be 1.49 moles per kilogram of solvent. So it's a different measurement from molarity, obviously, and it's going to be dependent on the solvent. So with that said, and the basic definition of molality, you should be able to do this problem. Remember, moles of the solute over kilograms of the solvent. And once you do that, then I have a repeat, I think to be. Yeah, so you only, that's a repeat. So you already did that. So what about this here? So what can we use molality for? Let's say, for example, that we have water. We know that water freezes at 0 degrees Celsius. That's pure water. So that would be the melting point, the freezing point or melting point for pure water. The moment we add something to it, now you're going to have other intermolecular forces involved, and that's going to affect the freezing point and even the boiling point. The freezing point of the solution is going to be lower, we know that the boiling point of water is 100 degrees Celsius. That's going to be higher. So the pure solvent, if we're talking about water, freezing melting point, which is the same thing, is 0 degrees. Boiling point or condensation is 100 degrees. But if you put something into the water, the freezing point is going to be lower than 0. The boiling point is going to be higher than 100. And it's because you're introducing new intermolecular forces. So how do we calculate the freezing point of the solution? Well, the formula we use for that is the change in temperature for the freezing point is going to be the molality times a constant for the solvent. On this particular case, the solvent is water. So we're going to have to see the value for water, which I don't have here. So let me find it on the internet real quick. I forgot to put it on my notes. So the constant for the freezing point of water is going to be, let's see, KF water. .86 degrees Celsius over molality. Let's find the boiling also. So the constant of boiling for water that would be KB and that's going to be 0.512 degrees Celsius over molality. So each solvent has its own value. So these are the values for water. If it was, for example, ethanol, it would have different values. So you have to find the value for the freezing and the value for the boiling. And then you apply these formulas. So the change in temperature for the freezing is the molality times the constant. The change in temperature for the boiling is going to be the molality times the constant for the water. So let's go ahead and do the freezing point. So the first thing we will have to do, let me go ahead and copy this somewhere. So those are the formulas that you already saw. We got those values already copied. So freezing point is going to be the change in temperature for the freezing is going to be the molality times 1.86 degrees Celsius over molality. So all we have to do is find the molality, right? And the molality is moles of solute over kilograms of the solvent. So moles of solute is going to be 55.8 grams of glucose over, let's change these to moles first. So 1 mole of glucose is going to be, this is going to be 72, 12, and 96. So 4, 10, it's going to be 0, 10, 11, 16. 160 grams, so that's going to be the moles, and we're going to divide that by the kilograms of the solvent, and the kilograms of the solvent is 455 grams, so 0.455 kilograms. Remember, it had 2 kilograms, So our molality is going to be then 55.8 divided by 160 divided by 0.455. It's going to be 0.766. So 0.766, that's the molality, times 1.86 degrees Celsius over molality. Molality cancels, and the change in freezing is going to be 0.766 times 1.86. It's going to be 1.4 degrees Celsius. So the problem wasn't asking for the change on freezing. The problem was asking for the freezing point of the solution. Well, we know that the freezing point of water is 0 degrees Celsius, but now we have a solution, and it's going to change by 1.4. And I told you that the freezing point is going to get lower, so the freezing point of this solution is going to be negative 1.4 degrees Celsius. Because you start at 0 and it's going to get lower by how much? This is going to be the change, right? So from 0 to going down on that change is going to be minus 1.5 degrees Celsius. So this solution will not freeze at 0 degrees like regular water. It's going to freeze below, and we know exactly at what point it's going to freeze. So the beauty of this is that if I'm working on something, and you can use this like you saw in the discussion probably to make ice cream or something like that, by changing the molality, by changing how much I put, I can control the change in temperature. So the bigger this number, the bigger the change is going to be. For example, if I need something to freeze at 2 degrees Celsius, at minus 2 degrees Celsius, I can play with how much of the solute I add until I get 2 degrees Celsius in here. So this is a very powerful formula to deal with something like that. Let's do the boiling. So we already know that the molality is 0.766. So molality equals 0.766 molality units. All right, so let's put the degrees Celsius over kilograms of the solvent. And to find the change in temperature for boiling, it's going to be the molality, 0.766, times the constant for the boiling, which is 0.512 degrees Celsius, over, over molality, and we say that these are the molality units. So that's going to cancel. And what we're going to get is that the change in the temperature of boiling is going to be 0.766 times 0.5112. And that's going to be 0.39, which means we know that the pure water boils at 100 degrees Celsius. We know that having a solid will make it bigger. So we're going to add 0.39. So instead of boiling at 100 degrees, now it's going to boil at 100.39 degrees Celsius. So you can see that the value for the boiling is almost 4 times smaller than the value for the freezing. So the change on the boiling is a lot smaller than the change that we observe on the freezing. So that's basically how you work these problems. You have to know the values for the solvent for freezing and boiling, and then you just use it on these formulas. And remember, we call these colligative properties because the property is affected by the amount of the solute. Like I told you, if I put a lot more or a lot less than 55.8 grams of glucose, the change in temperature is going to be different. So I'm affecting the property by changing the amount of the solute that I put in there. So based on that, you should be able to work these two problems. And once you do that, we're done with introducing you to what molality is and how it affects the freezing point and the boiling point when you create a mixture or a solution. So when you come back, we will finish this chapter. That will be the end of the chapter. And we will link this to biology and osmosis, which you can start using then the chemistry you know when you're talking about cells and other things in biology. So that's what we're doing next time when we meet again to finish the chapter. So for right now, we're going to leave it there. So talk to you soon.